Hi, and welcome to From WCF to gRPC. My name is Mark Rendle, and I was first exposed to the awesomeness that is gRPC last year at the Build conference. Microsoft announced that they were no longer going to be supporting the WCF framework for creating distributed applications in .NET Core and beyond. And they recommended that people migrate to gRPC, and they have built first-class support for gRPC into ASP.NET Core to facilitate that. So in this talk, I'm going to talk about how that's going to work, the differences between WCF and gRPC, and potential ways that customers who have big investments in WCF can migrate to gRPC running on .NET Core with a minimum of effort and disruption. So Microsoft have been on a journey with .NET for a few years now. They created .NET Core back in 2016. And unlike .NET, which has been a Windows-only behemoth of a framework and proprietary closed source, .NET Core is fully open source, developed in the open on GitHub, and it is cross-platform. It runs on Windows and Linux and Mac OS. And in the course of doing that, some things from .NET have been brought along. Some things have been changed along the way, and some things are just not being brought along at all. And one of those is WCF. WCF was created in 2006, and at the time, everybody who was doing distributed applications or service-oriented architecture, as we called it then, SOAP was built into WCF. It could do SOAP communications over HTTP. And when it was talking SOAP, it could talk to servers and clients written in other languages like Java or Python. It had a secondary mode, which was called NetTCP. And this was a much more high performance, much more powerful binding for WCF. And it used binary wire format and a raw TCP connection, and so it was much faster than SOAP, much more powerful. But the problem was it was only implemented in WCF, in .NET, and so WCF services and clients could communicate using NetTCP, but only with other .NET WCF clients and so forth. And then there was my favorite thing about WCF, and the thing that caused me to fail the WCF Microsoft Certified Developer exam twice, which was the configuration. So with WCF, the implementation of your service was completely separate from the specification of what bindings and contracts and wire formats and everything else it should use to actually handle communication between client and server. And all of this was done through the WCF configuration XML files. And this really doesn't fit with Microsoft's modern vision for .NET, .NET Core, and moving forward to the end of this year, .NET 5. A lot of what made WCF work was actually built into Windows and not the .NET framework itself. And Microsoft has finally embraced a cross-platform world, and in particular a world where people are running dense clusters of Linux containers in Kubernetes in various cloud platforms. And so supporting Linux as a target host operating system has become increasingly important. And re-implementing WCF to run on top of Linux would require not just migrating the .NET framework parts, but also the parts that are built into Windows would have to be re-implemented to work properly on Linux. And so Microsoft have decided it's 2020 and people are generally not using SOAP anymore, and NetTCP is too closed off and too Windows only, and so they have embraced gRPC. And gRPC compared to WCF, really provides the best of both worlds. Because gRPC is a binary protocol using protobuf, it gets NetTCP style performance, but of course gRPC is implemented on dozens of different platforms, and so we get the SOAP interoperability. And all of this is just out there, and Microsoft have embraced this and decided that they are going to become part of this gRPC ecosystem, which I'm sure we all agree is awesome. gRPC, of course, supports .NET and Java and Go, and an endless list. If it's a current programming language or a current development platform, you can be pretty certain it supports gRPC, whether that's officially or through third-party implementations for things like Rust and Haskell and so forth. One nice thing is that the gRPC web proxy standard, which is commonly used to allow browsers to access gRPC services, that normally requires running the gRPC web proxy in a container or using an Envoy proxy to provide the gRPC web interface. Microsoft have actually created an implementation of the gRPC web protocol, and it's built into ASP.NET Core. So you can install it just as an additional package into your gRPC application, and with a couple of configuration points, you can actually make your gRPC service natively support gRPC web and support browsers connecting to it without any need for proxies or other sidecar instances in production. So that's pretty cool. I think that's a good example of how Microsoft are actually embracing and attempting to really make the most of the gRPC ecosystem for both for Microsoft developers, but for all other developers as well. So .NET Core gRPC, Microsoft, obviously the gRPC project has provided NuGet packages to implement gRPC in .NET applications for some time now. And those, the libraries for .NET are wrappers around the native gRPC implementation library. .NET Core gRPC wanted to provide the gRPC protocol, but in a fully managed way that meshed well with .NET Core and ASP.NET Core applications. And so they dedicated some developers working on .NET Core 3.0 to create a .NET Core gRPC implementation, which is available alongside the original gRPC for .NET or gRPC for C# implementation. So .NET Core gRPC is fully managed. It doesn't use the gRPC native client at all, or native components at all. It is part of the gRPC project, though. It's under the gRPC organization on GitHub. It's maintained by Microsoft developers, but it's open source, and there are other contributors to it as well. And it is playing very nicely in the gRPC organization and ecosystem. And it runs on the Kestrel HTTP server, which is an incredibly high performance HTTP server that's built into .NET Core, which is currently sitting somewhere near the top of the Tech Empower benchmarks. And the clients that you generate for .NET Core use the system.net.http client, which again is a very high performance HTTP client that's natively implemented in .NET Core. So adding gRPC to an ASP.NET Core application looks much like adding anything else to an ASP.NET Core application. Here you can see the startup class that you get in all your ASP.NET Core applications, where we configure services, which is the dependency injection, and we just add gRPC as a dependency in there. And then in our configure method, which is where we set up our routing and endpoints and middleware and everything else, we just map our gRPC service. And this will sit quite happily in an application that also has HTTP endpoints or SignalR endpoints that's serving static files. It works with the built-in ASP.NET Core authentication libraries, encryption libraries, compression libraries. It is a full-on first-class part of the ASP.NET Core environment. So it's clear that Microsoft are all in on this, and that this is where we should be going with our distributed applications from WCF. So let's take a look at how WCF compares to gRPC in terms of the actual implementation. So the first thing we have as part of any RPC or distributed system is our services. And in WCF, these are defined using service contracts. Service contracts are typically a C# interface decorated with some attributes, and the attributes declare how the interface is going to be exposed as a service. You can put things in there to control authentication and various other components. But you define your service contract, your public interface, using this C# interface, and then you would implement that interface in an actual class in order to create the implementation of your service. In gRPC, we have a service definition, and this is written in the protobuf language, and it looks pretty much the same. Obviously, it's a first-class DSL for defining services and messages. There are a couple of key differences with WCF and gRPC. The primary one is that RPC methods in gRPC can only take a single parameter, whereas WCF methods in service contracts can take multiple parameters. Also, WCF methods can return all kinds of types. They can return plain old C# objects, but they can also return lists and arrays of C# objects, and they can also return lists and arrays of primitives. So you could have a method that returned a list of strings. Whereas RPC really just supports returning some kind of message type. And so the first part of migrating your WCF to gRPC application is to wrap those parameters in request objects and potentially wrap the return type in a response object. And when I'm working with customers who are looking to do this, I always recommend creating a specific request and response object for each method in the service, just because one of the great things about protobuf and gRPC is the forwards and backwards compatibility that you get from protobuf. And if we have separate request and response objects for each method, it means less chance of breaking the contract with an irreconcilable change in the future. Speaking of contracts, the next thing we want to look at is data contracts, or what gRPC calls messages. So in WCF, a data contract is simply a plain old C# object with properties, and again decorated with attributes. You have the data contract to say this is a data contract, and then you use the data member attribute to decorate all the properties that should be serialized. This matches fairly closely to a gRPC message. We have here the equivalent message for the room type. Obviously, in gRPC, we're using the lowercase and underscores naming convention. In the generated C# code, that will become Pascal case because that's the way the C# code generator works. One thing that I ran into fairly quickly, particularly working with enterprise customers, is that protobuf does not provide a built-in type that matches to C#'s decimal. It has float and it has double, and we know that actually if you set a float on a protobuf object and send it over the wire and then extract that float at the other end, it will still have exactly the same value. And it's when you do maths with floats that you discover that 4.99 times 5 is 24.944444449. But if you try and put floats and doubles into a lot of enterprise customer software, they're not happy. They don't like it. And so I had to find a way around this. Google, within their API protobuf definitions actually provide a money type, which works by having units and nanos and a currency field. And so I just created a copy of that money type and left off the currency and called that decimal. So this is almost identical to Google's money proto from their APIs. The only difference is it doesn't have the currency field on there. So this builds quite nicely into a .NET Core gRPC application. You just drop this proto in, and to make it even nicer and to make it play nicely with the built-in decimals in C#, I use the fact that the classes generated by protobufs, by gRPC and protobufs C# generator, it declares all the classes as partial, and that means that you can add additional properties and methods and other things to them. And in this instance, it means that we can add some implicit operators to our decimal value class to allow it to be passed backwards and forwards with C# decimals without any casting or overloads or methods or anything like that. So this makes that decimal value type play nicely with C# decimals. As I tend to be working with people who are moving from WCF to gRPC, they usually already have a C# equivalent of their data contract object, their message object as well. And so what we quite often do is build a similar implicit conversion in to go from the plain old C# object to the gRPC message. As you can see here, this converts the global : hotel data room. That would be the pre-existing class from their old WCF application, and this partial declaration just cleanly converts between that type and the protobuf generated room message type. Okay, so that makes migration a little bit easier. Then we get into the actual implementation in WCF versus gRPC. So with WCF, you don't have a base class. You inherit from the interface that you use to define your service contract, and then you just have methods on there that are implemented however you want to implement them. gRPC implementations are different. Obviously, you get a base class and you inherit from that base class and override the predefined methods to provide the implementation for your service. And so that makes things a little bit different. Also, because for date and times and durations, there is no built-in implicit conversion between Google's well-known timestamp and duration types to .NET's built-in date-time offset and time span types. We do actually have to do some manual conversion there. So we have to turn the check-in date, which is a timestamp, to a date-time offset. Then we create our room data class wherever that's coming from. Obviously, normally in a .NET Core application, we'd be getting that from dependency injection, but in this case, this is just for some demo code. And then we create our response from the protobuf message. And in this instance, because this is not asynchronous, we just return a task from result response. But normally, obviously, this would be talking to databases or upstream services or other microservices, and so we would have various awaits in there. So this essentially moves the functionality from the old hotel service directly into the gRPC service in the new project. However, there is an easier way to do this. Obviously, this hotel service, there's not a lot going on in that implementation. The majority of WCF services, there will be quite a bit more logic in each of those implementation methods, and there may also be other private methods in that hotel service class that are used to fulfill these requests. And so there's a quick cheat mode that I like to recommend, where if you can get your hotel service type to compile under .NET Core, which as long as you're not using particularly edge case libraries or NuGet packages, you should be able to do. .NET Core 3.1 and .NET 5 support ADO.NET for most of the databases out there. They also support Entity Framework 6.3 as well as Entity Framework Core. So if you can copy your hotel service class across into your new project, then we can actually just inject that service contract type into our gRPC service implementation and just call directly into it. So all our old code stays in the same place and working the same way. We just wrap gRPC around it, and then we find it much easier to bring complex data across. And so you can see here, hotel service is injected by dependency injection, and then get available rooms just calls into that service contract get available rooms. So whatever logic was in there is now being exposed over a gRPC interface. So that works really nicely. And actually, I make a tool which I'll mention briefly later on that automates as much of this process as possible. And this is the pattern that it uses to migrate .NET 4 WCF code into a .NET Core 3.1 gRPC application. So gRPC has various modes, and WCF has various different bindings and types of service that it supports. And so I want to talk about those briefly. WCF, the most straightforward mode, and the mode that we've just been looking at with that hotel service, is just simple request response. The client sends a request, the server sends a response, and that's very straightforward, and that maps perfectly to gRPC's request response model, and makes it very, very easy to copy things over. gRPC also provides server streaming, where the call from the client to the server opens a persistent stream, and then objects are sent one at a time over that stream, either until there are no more objects to send or until the client closes the stream again. And WCF could do something like this in certain bindings in NetTCP, and I think a couple of other bindings. If you returned an IEnumerable from your WCF service, it would actually send the objects over the wire as they became available. And so you could get this server streaming kind of approach. And so for WCF methods that return IEnumerable of something, you can map that very nicely to a gRPC streaming service, which in C# looks like the code on the right here, where we get our response stream passed in, and then we just enumerate through all the rooms from our service contract and write those back to the response stream. And this gives us, if you were using NetTCP binding and using that feature of IEnumerable, this gives you the same functionality. If you weren't using a binding that supported it, then in WCF this would actually build the entire result set on the server side and then send the whole thing over in one go. And so moving to a gRPC streaming approach gives you actually extra benefits over what you could do in WCF. And then finally, gRPC, I'm going the wrong way. And then finally, gRPC supports bidirectional streaming, where you have a stream open from the client to the server and a stream open from the server to the client, and objects can just be asynchronously, arbitrarily sent in both directions at the same time. And this actually maps sort of to WCF full duplex bindings. And WCF had this concept of session. So a full duplex binding in WCF would mean that the client had a stub which it could use to call methods on the server, and the server had a stub which it could use to call methods on the client. And this allowed for quite complicated services to be built with asynchronous messaging between them. It also meant that when an instance of the service contract type was created on the server, it could be held in memory, and it basically created a persistent session that the client was permanently connected to. So if you had any fields, for example, on that class, then those fields would keep their value for as long as that session stayed open, for as long as the duplex binding was held. A duplex binding in WCF looked something like this. So we would have our calculator service. This is Microsoft's canonical example of almost anything ever is a calculator. And so they illustrated the duplex service with a calculator where the client just kept sending new values, and the server kept calling back a message on the client saying, here's the current result, here's the current result. And so that was implemented something like this, where you would get the callback interface, which was a proxy obviously wrapped around the interface declaration, and then you could use that to call methods on the client, which obviously was something about sending a message and then invoking something on the client with that message's parameters. And we can actually duplicate this in gRPC with, I like to call them action streams. So if we have a bidirectional streaming service in gRPC, and we have a stream of actions from the client to the server and a stream of callbacks from the server to the client, and each of these message types has a one-of field, and that one-of is set to more message types. So in this instance, we have a clear action and an add to action and so on. And the callback has a result callback and an equation callback. And so rather than looking like it's calling a method on the server and a method on the client, we send different messages between the server and the client and then respond to those accordingly, which looks something like this in the implementation. So this is our our start method there, opens the streams and then runs them effectively. It reads all the incoming messages off the request stream, does a switch on the action case, which is how the C# code gen in gRPC and protobuf says this is the one-of field that was set, and invokes the relevant method based on which one of those values was set. This is a fairly simple implementation. You can get yourself tied in knots with tasks and threading and so forth. But again, this does provide a way to map from a WCF duplex service to a gRPC service and achieve the same end result. We can even wrap our response stream with a class that implements the old callback interface, which would look something like this. So here we have our iCalculator callback, which is what the old WCF code would have been looking at to talk back to the client. And we can just wrap the response stream and implement the same methods and just write these callback messages onto the response stream and do something similar on the client side to invoke those methods. And again, my tooling for doing this will automatically generate most of the code for doing that, but it is possible to implement it manually as well. So that basically covers most of the functionality. There are a couple more points I want to mention. There is the security aspect. So with WCF, because it was .NET only, because it was Windows only, it meant you could use basic authentication. You could use NTLM or Kerberos or Windows authentication. Also, WCF didn't natively support encryption, but there were the WS encryption standards, and you could run it over an HTTPS connection if you were doing SOAP over HTTP. gRPC, because it uses HTTP2, Kerberos Windows authentication is actually impossible. You just can't do it. HTTP2 does not support it. And so with gRPC, the standard authentication method is bearer tokens. You can combine that with ADFS. You can get tokens from your Active Directory Federation server, and then you can use those as bearer tokens in your gRPC application, and then you can use the ASP.NET Core built-in ADFS authentication library to authenticate those calls on the server. And obviously gRPC also provides mutual TLS, where the client and server both provide a certificate, and all communication is encrypted using that certificate, and it also means that both sides can verify that the other party is the correct thing they are expecting to be connected to. The final thing that I think is very interesting for all these .NET shops who are finding their way in this new world of gRPC is, if they've been running on .NET, they are going to be used to a world of Windows servers, just the .NET framework, IIS web farms, and that sort of thing. And I think there's a lot of companies out there who are going to be looking at things like Docker and Kubernetes and service meshes, whether that's on-premise or in different cloud environments. And I think there's going to be some good opportunities for people to work with companies like that on a consulting or training basis to provide an introduction to the new ways of hosting applications now that .NET Core runs nicely on Linux platforms as well as Windows. If you'd like more detail on anything I've talked about in this presentation, I have co-authored a book called gRPC for WCF Developers, which is published for free on Microsoft's website in their architecture and patterns area of their documentation website, which you can find at that URL. I have spent much of the last 18 months working on Visual Recode, which is a tool that will automatically take your WCF code and, using some of the patterns that I've talked about here and some additional tricks, automatically migrate it to ASP.NET Core gRPC. It is a commercial project because it was too big to do as open source, and it's properly supported with support contracts and consulting and so forth. But that is available if anybody is interested in that. At the moment, it does ASP.NET Core WCF to gRPC. It will be doing some additional types of conversion as well, but that is available at visualrecode.com. I hope that was helpful. I hope it was informative. I hope you enjoyed it, and I hope that if you are using WCF, this has made you see that gRPC can fulfill that need for you. And if you're already using gRPC, then maybe reach out to some WCF teams, if you know any, and try and evangelize gRPC to them and show them everything that it can do for them. Thank you very much, and enjoy the rest of the conference.